Okay, practice addition reaction questions. Okay, what's the product between the reaction between propene and steam? Steam is another word for water, and propene is an alkene, and so we're dealing with addition reactions here. So if we think of reaction Jackson, we are thinking of the different reactions that come out of the alkene at the top of the chart. Those reactions are adding bromine, adding hydrogen and a halogen, adding water, or adding something to itself to make a polymer chain. So those are going to be our different reactions. If I add water, I'm going to add H and OH to something. I'm going to add that where the double bond used to be in the molecule. So if I think of propene, I think of CH3, and then I think of a double bond between carbons. If I want to fill these out, then there should be two H's on the end and one in the middle. And now if I want to see what's going to form in the reaction, I'm going to get rid of this extra bond, the double bond. So let's erase that. And I'm going to add the two new things onto each carbon. So what is the product of the reaction between propene and steam? Well, it's going to be a 3-carbon molecule with an OH on it, and therefore it's going to be propanol. Now, it sort of depends on what the question, this is maybe not such a specific question, it just says what is the product. The actual IB exam question would probably ask for the name, or it would ask for the chemical formula. So I've drawn the structural formula here of one of the possible products, and this one is called propan-1-ol. But it's also possible that we could have switched the H and the OH around, and I should get an OH here and I get an H there. And this is actually the more likely product, the major product as they'd call it. That's more of an HL topic, but generally, yeah, you're going to end up forming and getting the OH adding in the more central carbon, but the HL will focus on that in a separate video. If you just needed to give like a chemical formula of the product, then you could give it in a more condensed way, like CH3, CH2, CH2OH for propan-1-ol, and CH3, CHOH, CH3 for propan-2-ol. So that's a condensed structural formula versus a full structural formula versus a name. So my question that I wrote here is not all that clear. These are all variations on how you might give the answer. And even more generic, would be C3H7OH. That would just be closer to a molecular formula. Okay, anyways, moving on. Question 2. Write the chemical equation for the reaction between ethene, C2H4, and hydrogen, H2, and the conditions needed. Well, this is the hydrogenation reaction, and so we're just going to add the hydrogen and make C2H6, this making ethane, and the condition needed is nickel metal as a catalyst. Determine the structural formulas of the two possible products of the reaction between hydrogen chloride and but-1-ene. So this is the idea I talked about with the propanol at the beginning. If it's but-1-ene, then the double bond is right at the beginning, and there must be 2 more carbons coming off of here, and a hydrogen coming off of there. Now, if I want to write that condensed, I could get rid of this long carbon chain. Why is that? There we go. Okay. I could get rid of that, and I could write something like C2H5. It would be a little more condensed. Now, the HCl can add H here and Cl there. Or you could add Cl on the left and H on the right. So those are going to be the 2 different ways that we can add hydrogen chloride onto an alkene. So the 2 possible products, if we draw them out, we've got CH3, CH2, and then we could have, oh yeah, sorry, I'm getting confused by my 2 drawings. I could have CH2 and then CH2Cl. That's if the chlorine adds to the end. Or if I did the other way around, I'd get CH3CH2, and then the chlorine adds here on the second carbon, and at the end we would have 3 hydrogens. So I could have 1 chlorobutane, or I could have 2 chlorobutane. Those are the 2 options. Okay, number 4, state the name of the following reaction and explain one use. So this is bromination. Probably best these days to just call this an addition reaction. Yes, you could also, maybe you could add bromination, but the real general type of reaction happening here is addition. And in the context, if you were doing this on the IB exam, where all the possible reactions are a possible answer, then they're seeing if you recognize this as an addition reaction. The use of bromination is to distinguish between alkenes and alkanes. So in this reaction, we are starting with an alkene. Alkenes very rapidly react with bromine and decolorize the bromine. So the bromine is reddish brown, and its color will very quickly disappear if there are any C to C double or triple bonds readily available to react with it. If it's an alkane, it can only really react with that bromine if there's some ultraviolet light present, which will initiate the free radical substitution mechanism. But assuming all other things being equal, it's really only going to quickly react if you've got some carbon-carbon pi bonds, some extra bonds. So alkynes and alkenes will react with the bromine, but the alkanes won't. Okay, what reactants and conditions are needed to produce propane-2-ol in a one-step reaction? Well, it doesn't really tell you what you're starting with. Let's assume we're like in question 1, we're starting with propene. So what we need is water, preferably steam, so water and a lot of heat, and then H2SO4 as a catalyst. 3-chloropropene acts as a monomer for a polymer. Let's draw out 3-chloropropene, so 3 carbons. They've implied that chlorine is on number 3, and that implies that the double bond must be between the 1 and 2. So if I now add the rest of the hydrogens, it would look like this. Okay, draw the repeating unit. So when I'm thinking of a polymer, it's always going to focus around the double bond. So I'm going to stick the other things coming off of those carbons up and down. So there's H's coming off of this carbon, and then off of this second carbon, there's an H, and then there's this group. So I'm going to draw H, and I'm going to draw CH2Cl. It doesn't matter which ones point up or down. This is the monomer. If I want to turn it into the repeating unit, I get rid of one of the bonds, and instead I add bond extensions that show that this now repeats itself n number of times, and these extension bonds are necessary for the mark. They don't have to be quite that long, but that's the idea. So just get rid of the double bond and replace it with extension bonds. Focus the repeating unit around the 2 carbons that have the alkene group. Okay, now you're given a section of a polymer. Determine the structural formula and name of the monomer. Well, I can see that it repeats. I'm looking for 2 carbon units that are repeating. So I can see that that structure is repeating each time. If I now draw that, all I do is get rid of the bonds on either side of those 2 carbons and instead put a double bond. So now I just copy HH, H, and CH3. So that's the monomer, and that would be called propene. Okay, there's a mistake in question 8. It should say bromoethane can be produced by both a 1-step and a 2-step process beginning with ethene. So that's my fault. Sorry about that. State the type of reaction that can do it in 1 step. Well, if we're doing it in 1 step and we're starting with an alkene, then we must be doing an addition reaction. That's the type of reactions that alkenes do. So we can take ethene, C2H4, and if we're making bromoethane, we'd have C2H5Br. Get rid of the double bond, we need to add a H and a Br. Therefore, the other chemical needed would be HBr. There aren't any special conditions needed for this reaction. This is halogenation, which is a type of addition reaction. If you're going to do it in 2 steps, then you're still going to start with an addition reaction. The other way that we know how to make halogenoalkanes is via free radical substitution. Free radical substitution starts with alkanes, so I would be starting here with C2H6 and adding Br2 plus some UV light, and I would make C2H5Br plus HBr, plus maybe some other byproducts, but that's sort of the overall reaction they'd expect you to know. So how do I turn, in the first step, ethene into ethane? Well, that is by adding hydrogen. I can see I have 4 H's. Here there's 6, so I must add 2 more. So that's an addition reaction with a nickel catalyst. And then outline a method to distinguish propane and propene. Well, now we're talking about bromination again, right? So add bromine to both, or add bromine water to both. Bromine water is a safer way to do this test than adding pure bromine, which is quite toxic and very volatile liquid that you wouldn't want to breathe in. So the bromine water also works. And when the color disappears, then you know you've got an alkene, so you've got propene. And if the color stays, then you've got propane. And it's a brown-red color. And those are the answers to the SL addition questions.